Recording started.
So the first questions we're going to do are going to be kind of more basic ones, and then we're going to move into the calculation ones. If you could just ignore what's on the screen, I should have put it a little bit further down. But so first questions, question number 3 says acids produce what type of ions in water? Yeah, exactly. Don't look at the answers. So what type of ions do acids produce in water? This one might be a little surprise. Okay, what I'm looking at is, and we get into it in lesson 12, is they're called hydronium ions. And you can see here it's H3O+. Now, in the past, when we've looked at what type of ions they produce, we've talked about them producing protons, or just H+, right? And that's kind of the initial answer when you're first getting into, yeah, exactly. When you're first getting into to chemistry, you talk about acids producing H+. So if you're talking about like HCl, that's okay. HCl produces H+ in water, right? So that's a type of acid. Or H2SO4, you know, sulfuric acid. Normally we thought of it producing H+. But as we go on in chemistry, we learn that it's actually H3O+, which is called a hydronium ion. So we can kind of think of H3O+ as being similar to H+. It's actually different. What it is you can look at it as protonated water if you want. Water with a proton. In other words, water is usually H2O, and now it's got an extra proton, which makes it H3O+. Okay? That's what a hydronium ion is. And then the second question here says bases produce what type of ion, and that's OH- ions or hydroxide ions. Okay? So we'll go into a little bit more about this hydronium ion stuff, but let's just know that for now. And so if you're looking at pure water is going to dissociate into both these ions, right? And it's going to dissociate into both in equal concentrations, and that's why you're going to have a pH of 7. Okay, so when you've got equal concentrations of OH and H3O+, you've got a pH of 7. And so I just wrote here, think of these two things as being the same thing. So let's go on to the next question. Now the next question is talking about this chart that's kind of comparing different concentrations of H3O+, and we're just going to make a note of something here. So it says here, what 2 observations can you make by examining this table? And so one of the ones you can make is that as the hydronium ion, or H3O+, goes up, okay, so it's going up this way, these numbers are getting larger, then the pH is decreasing. In other words, it's becoming more acidic. Okay, so as you're getting a larger concentration of H3O+, or in other words, H+ ions, the pH is decreasing, it's becoming more acidic, right? But as pH increases, so you can see that pH is, okay, so as pH decreases, POH increases. And we're going to talk about what POH is in just a sec here. Okay, that's kind of a new concept, POH. So basically, POH and pH equal 14. Okay, we know that that's the maximum pH you can have. pH values go from 0 to 14. So if you ever want to, if you know what the pH is, and you know it's say 5, and you want to find out what the POH is, it's going to be it's going to be 9, right? Okay, since 9 and 5 is 14. Okay, so that's the way that works. And the other observation you can make from this table is that each pH change of 1 represents a 10-fold change in the concentration of H3O+. Okay? So you've got 10 times as much of that hydronium ion kicking around in the solution each time you have a change of pH. So when you're going from a pH of 8 to 9, of course, that's becoming more basic. So you're going to have 1/10 as much of the H3O+ concentration. Okay? So that's basically all we're talking about from the table. So yeah, like you said, it's a 10-fold, right? Okay, so those are 2 observations we can make from the table. Oh, what do I mean by tenfold? I mean 10 times as much. So,
you have new mail.
You know, like, for instance, yeah, just like the number 1 compared to 10, or 10 compared to 100 sort of thing, 100 compared to 10. It's also similar to logarithmic scale like you have with earthquakes. It's 10 times as much as well. Okay, so let's go on to a few calculation questions. So this one says calculate the pH. And so the formula we use to calculate pH, we're going to use something called logarithms. Okay? So if you look on your calculator, you got a calculator kicking around there? Okay. Okay, so I won't go into exactly what logarithms are, but for now, if you just want to know that it's a special type of math function, and let's just see if I have something I can draw a curved line with here. So if you had a graph of a logarithm, it would look kind of like this. All right, and as you go higher up in math, you'll get into logs. And so basically we're just using the log function on our calculator, and I believe it does talk about logs in the lesson. So all you need to do then is if you want to find the pH and you're told a certain concentration like we are here, so we're told that the concentration of H2O plus is this many moles per liter, all we need to do is take this number and we need to find the negative log of it, and that'll give us the pH. So what we do is we find the log, and then we use that button that says plus minus, and we switch it from negative to plus. Okay, so why don't you try that out? Put on your calculator 4 times 10, and then press, y to the x. Press 8, and then the plus minus button, and then press equal, and it should give you like decimal 0.0000 whatever 4. Okay, got that so far? Okay, so what we do is on your calculator, we're inputting this number, right? So what you do is you press 4, and then you press times, and then you press 10. You press the y to the x button, and then we're going to tell the calculator what the power is. So we're going to make it 8, and then we're going to press, you must have some button that changes between plus and minus. It'll have plus and minus on it. You press that button, and then you press equal. And when you do that, you should get decimal, you should have 7 zeros, a decimal, 7 zeros, and a 4. So do you have that at this point? Okay, well it's probably just a different way of writing it. Let's see if we get the right answer. So now that we've got it input into the calculator, this number, we want to take the log of it. So press the log button. And when you do that, do you get minus 7.39, etc.? Okay, good stuff. And now press the plus minus button, and it'll make it 7.39, and so we're just going to round that to 7.40. Okay? All right, shall we go to the next one? CI83 plus. Okay. Yeah, that's right. If you do have another calculator kicking around, sometimes other ones are better for just basic calculations. So let's go on to the next question. So again, to find the pH, we just use this formula here, and after, first of all, inputting the concentration of H0 plus into our calculator. Okay, so let's go on to the next one. Okay, the next one says to find the pOH, and let's look at how we do this. So I just wrote here, first of all, pH measures how acidic a substance is, pOH measures how basic it is. Excuse me. And again, it's all kind of relative, right? Because at the same time pH is measuring how acidic a substance is, it's also measuring how basic it is. They're both kind of on the same spectrum, acidity and basicity. You know, so when you're talking about one, you're always kind of talking about the other. So we use this formula, pH plus pOH equals 14. Really important formula. That's right. So this question here, question 5, is saying calculate the pOH of a compound that has a concentration of OH, which is this. Okay? So it's similar to the other one. So instead of having pOH or pH equals minus the log of the hydronium concentration, we got pOH equals minus the log of the hydroxide concentration. So we just plug this number in, and again, we would use our calculator, we would take minus the log of this number, and then we get 10.51. Okay, so I think you can see this is pretty similar to the other one. You're just using a different formula. You're using one for pOH instead of pH. And we knew that we were using it for pOH because we were given the concentration of OH, right? Okay, so let's go to the next one. We're going to get a little more complicated at this point. So, I think this was our next one. Let's see. I don't think I skipped one. No. Okay, so this question here, it says calculate the pH of a solution made by dissolving 5.51 grams of HI, okay, so that's an acid, in enough water to make 150 mils. Okay, so what do we need to do? We need to find the pH. How are we going to do it? Well, I wrote down here, we need to find the pH, so we use the formula for finding pH. pH equals minus the log of the hydronium concentration. And I should have put that plus inside. Okay, so how are we going to do that then? We need to find, to use this formula, we need to have the concentration of, we'll just think of it as H plus, right? But what is the concentration of H plus in moles per liter? That's what we're always using it in this formula, is moles per liter. What is it? If we look at our question, we don't see it anywhere, the concentration of H plus. So how are we going to find it? Well, in order to find the concentration of H plus, first of all, it's in moles per liter. We don't have 1 liter, we have 150 mils. So we can find how many moles of H plus we have in 150 mils, and then later on we can make that into liters, and then we can find moles per liter. Now, here's something really important to notice. We're looking for the concentration of H plus. Eventually we're looking for it in moles per liter to use in this formula. But in the question, we're given not H plus, we're given the number of moles, or we're given HI, and so we need to deal with moles of HI. But the thing that you can recognize here is whenever you've got a mole of HI, you've also got a mole of H plus, right? Because each mole of HI is equal to a mole of H plus and a mole of I, right? Okay? So that's something that we can, that's really important to note, because you know, we're given HI in the formula, and then we've got to somehow produce the number of moles per liter of H+. But they're going to be the same, right? Okay? So we're needing to find how many moles of H we have in 150 mils, and we're looking basically for the number of moles of HI in 150 mils, knowing they're going to be the same number, those moles. Okay? So what we do then is we go to the periodic table, right? And we know that 1 mole of HI is this much. We add it up, and we get 127.91 grams. Okay, so now we know how much 1 mole of HI is. What do we do with that? Well, we make it into the number of moles that we have. We've been given 5.15 grams for the number of moles we have in the solution. So we figure out using this that we have 0.04 moles of HI. Okay, so we know we have 0.04 moles of HI in 150 mils. But what are we eventually looking for? We're looking for the number of moles of HI in 1,000 mils, or in other words, moles per liter, which is the same as the number of moles of H+ per liter. Okay? So we've got this many moles of HI in this many mils. So let's see what we'll do next. Okay, so since we have this many moles of HI, we also have this many moles of H+. We know that. Let's go to the next screen. Okay, so we have this many moles of H+ in 150 mils. We have X moles of H+ in 1,000. I should have said mils, not liters. Okay, and so we set up our proportion, and so we've got 0.04 over X is equal to 150 over 1,000. We do the math. Okay, 150x equals 40. We divide both sides by 150, and we get X equals 0.267. And so again, that is the concentration of H+ or hydronium, the number of moles of it per liter. Okay? So now that we've got that concentration in moles per liter, we can find pH, because our formula for pH involves the concentration of this in moles per liter, right? So let's go to that. Okay. So all we do is we say pH equals minus the log of this here. We plug in the value that we got, and we get this for pH. So does that make sense? I know if you haven't done this one, it'll make more sense when you go over it the next time. Did it sort of make sense?
You have new mail.
Okay. All right. And, you know, if you have a question at any point, just stop me, okay? All right. Good stuff. So let's look at the next one here. Next one says, calculate the pH of a solution made by dissolving 1.75 kilograms of NaOH in enough water to make 1,000 liters of solution. Okay, so how are we going to do this? We've got to find pH. And we've been given a base. Okay, and somehow using this base, we've got to find a pH. So what are we going to do? Let's look at here's the overall solution. We know we can find pOH using the NaOH, okay, because it's got OH in it, and so somehow we can find the concentration of the OH, and that can help us find pOH. Once we find pOH, eventually we can use this formula, pH plus pOH equals 14. Okay, we're just going to do a subtraction, and we'll find pH. So we need to find the pOH of the NaOH that we have in the solution. Okay? So how are we going to do that? Well, we know that this is our overall formula, pOH equals minus the log of the concentration of OH. So we need to find the concentration of OH, and that always needs to be in moles per liter. Okay, so that's what we need to find, the concentration of OH in moles per liter. So how are we going to do that? Well, the question tells us we have 1.75 grams in 1,000 liters. So eventually we've got to get that, or kilograms, we've got to get that kilograms in 1,000 liters. Eventually we've got to somehow convert that into moles per liter in the end. And we know that when we've got mass, that we can convert from mass to moles, right? So we've got to somehow do that. And so we've got 1.75 kilograms in 1,000 liters. And I said that's 1,750 grams in 1,000 liters, because we want to work with grams when we're working with the periodic table, right? And we need to find grams per liter because we're going to change those grams per liter into moles per liter, right? That's what we're trying to find, moles per liter of OH concentration. So, okay, so we have 1750 grams of NaOH in 1,000 liters. And what we do is we make that for 1 liter, we would divide by 1,000, and so we divide that by 1,000 as well. So in 1 liter of NaOH, we would have 1.75 grams. And now that we know how many grams we have of NaOH in 1 liter, we can find the moles per liter. We just change grams to moles using the periodic table. Okay, so we go to the next screen. All right, so I'm just going to recap what we've been doing so far. So again, we're trying to find PaOH of NaOH, so later we can find the pH, which is what the question is after. So to find PaOH, we're going to use this formula, which involves the concentration of OH. So we need to find OH in moles per liter. So far, we know we have 1.7 grams of NaOH in 1 liter, and we need to change it from grams per liter into moles per liter. So what we do is we look at the fact that 1 mole of NaOH is 40 grams. So we change, basically we do the conversion to see how many moles we have. How much is 1.75 grams going to be? It's going to be this many moles using this calculation. Okay, so we find out how many moles we have of NaOH, and so we know that if we have this many grams of NaOH per liter, we have this many moles of NaOH per liter. So now that we have the concentration of OH in moles per liter, we can use that formula for POH, which is minus the log of the concentration of OH, and then so then we'll know POH, and then eventually we can find pH. Okay, so let's go to the next screen. The next screen, okay, so we're going to just use the formula for POH. POH equals minus the log of OH, which we calculated to be the OH concentration to be that much. So we do the math, and we get POH to equal that. And then we use this formula that helps us find pH by just subtracting this 1.36 from 14, and that's going to give us 12.64. So I know that one, again, there's a lot to it, and with all these chemistry questions, it's a matter of looking at what you have, what you need, what's the first step you can do. Once you do that first step, what will that allow you to use, you know? And sometimes with these questions, I just find that, you know, even myself, I don't always necessarily know right from scratch when I look at it what I'm going to do, but you just kind of look at it and you say, okay, I know this can get me this, and this could get me this, you know, and I can change this into this. And so a lot of times it's just kind of figuring out what you have and just converting something into something and saying, well, where can I go from here? And as you do these more and more, you can sometimes get the bigger picture of what the whole series of stuff is going to be. But sometimes just being able to get that first step and then saying, okay, where am I going to go from that? Is a really good way to go. So, okay, so we got that one, and let's look at the next one. Okay, so the next question says, calculate the concentration of H3O+ given the following. Now you notice what we're doing here is the opposite of what we did earlier. Earlier we said, okay, we've got this much concentration of H3O+ in a certain acid, find me the pH. And so earlier we used the formula that was like pH equals the minus log of the hydronium ion concentration. This time we're doing the opposite. We're going from pH, which we're being given, we're using that to find H3O+. So we need a whole new formula to do this. And so here's what the formula is. The formula is the concentration of the hydronium ion, or H+ ion, is 10 to the minus pH. Okay, so that's another really important formula. So once we plug that in, we'll be able to find out what the formula is, or what the concentration is for hydronium ion given the initial pH. And you'll find out that the concentration, or sorry, the formula I should say, for the concentration of OH is going to be the exact same, except it's going to be 10 to the minus POH. Okay? So all we do here is we plug in, since it's 10 to the minus pH, and our pH is 4.21, we make it 10 to the minus 4.21. And when we do that, we get this. And then we just convert it into scientific notation, which is, as you know, you just start with your decimal here, and then you can go, you know, you go 10 to the minus 1, minus 2, minus 3, minus 4, minus 5. And so that's what our answer is, 6.17 times 10 to the minus 5. Okay? All right. So, next question is going to be, I think it might be a little more challenging. Let's have a look. Okay, the next one, actually, do you want to just take a break, get a drink or something like that? Okay, no, I'm good. All right, so the next one says, what is the mass of potassium hydroxide, KOH, which would have to be dissolved in enough water to make 300 mL of a solution with pH of 9.5? So just as you read this over, you'll notice we've got OH and we've got pH. And whenever you've got the combination of OH or POH and something that relates to pH, you know you've got to do some conversion. You've got to convert one of them into the other, because you've got two different, you know, it's kind of like apples and oranges. So somehow we've got to make them into the same units if you want. So I just wrote down here, in this question we have KOH and we have pH. Since we are asked to find the mass of KOH, we know that we are going to have to find moles of KOH to help us do that. Okay, so that's the first thing we know. Whenever we see mass, we say, okay, I know I'm going to be involving moles. And once you think about the fact that you're going to be involving moles of KOH, then you think, well, I'll probably be involving moles per liter of KOH, and then what formula is that going to involve? So, okay, so I know I'm going to have some formula that involves OH, and so what we can do is change everything into OH. So because we've been given pH of 9.5, we can change that into POH, and that way we'll have everything as OH kind of values. So what we do then is we use this formula, and so we say POH plus 9.5 equals 14, and so our POH equals 4.5. So now this becomes a POH of 4.5, and now we've got OH here, and this is OH, and everything's OH. And we'll be able to make some more headway now at this point. Okay, so now that we have POH, we know we're going to use it somehow, some formula that involves POH, because we've got POH, and we know that we're not just going to convert to POH without doing something with it. So we're going to look for some formula that involves POH. Yeah, it's a good question. I'm not sure, but hopefully next week we'll get back on track. But hey, at least we can talk about hockey, right? Okay, so we know we're going to do some formula that involves POH. So we're just going to recap here. We need to find the mass of KOH, and we know we're going to use moles of KOH to do this. And we changed pH 9.5 into POH 4.5, and we're looking for a formula that involves POH. So the question is, we have two different formulas that could involve POH. We could use this one, POH equals minus the log of the OH concentration. And if we did that, we'd plug in the POH value we have, which was 4.5, and we'd have this here to work with. Or we could use this formula, the other one that we introduced, right? And if we do that and we plug in the POH value, we've got this formula, right? So the question is, which one do you think we're going to use? Any ideas on which one we'd use? That's right, we're going to use the bottom one. And the reason is because on the bottom one we have everything we need to find the answer. We can find the concentration of OH. Whereas with this one, we don't know how we're going to find the concentration of OH using, somehow we've got to use this negative log to do it, and we don't know how to do it. So we know we're going to find the concentration of OH. And so here's what we do. Okay, so I just explained that, why we're going to use that one. And so we use that to find the concentration of OH, and we plug in 10 to the minus 4.5, and we get this as an answer. So we found the concentration of OH. Okay, so where does that get us? That's the question, right? Remember, we're ultimately looking for the mass of hydroxide, right? And we're going to get that by looking at the moles of hydroxide of OH. And we have a concentration of OH, so that can help us find moles of OH, which can then help us find mass of OH. So let's look on the next screen. Okay, so again, I just recapped everything we did, and POH helped us to find the concentration of OH in moles per liters. Where will that get us? We need to find a mass of KOH. We'll use moles of KOH to get this. We know we have this many moles of KOH in 1,000 mils. We need to know how many moles we have in 300 mils, because that's how many mils we have in our question. So, since each mole of KOH has 1 mole of OH minus in it, okay, there's again a 1-to-1 ratio between the number of moles of this whole thing and the number of moles of OH, right? So let's find the number of moles that we have in 300 mils. So we know that we had this many moles in 1,000 mils, because we found our concentration in moles per liter, and we set up a ratio to find the number of moles we have in 300 mils. So we do the proportion, and we do the math, and solve for x, and we're going to find how many moles of KOH we have in 300 mils. So when we do that, we do the math, and we get this many moles per 300 mils. And so now we've got moles, and we need to find mass. And we know how to do that because we know 1 mole of KOH is 56.11 grams. So all we do is we multiply the number of moles we got by the number of grams, the number of moles per grams per 1 mole, right? That's what this is. So we're multiplying, or sorry, that's what this is. 56.11 grams per 1 mole times however many moles we have gives us this many grams. And so we found the number of grams of KOH. And we can write in scientific notation as well. Okay? So again, I know this one was, it's a multi-step question, a lot of steps in it, and it involves a lot of figuring out, you know, what you have, what you need. And again, right off the bat, you notice you have KOH, so you've got OH, and you've got pH, and you've got to somehow make those both either OH or pH so that you can get further. And other than that, it's basically just a series of figuring out what you know and what you need to get and that sort of thing. Okay, so again, I know that this stuff is it's kind of new to you, and I think as you practice this and if you go over the recording later on, it'll make more sense. And I can also send you over the like I can send you the sheet as well that I used for this recording, the sheet that we've gone through here, because that can help as well. Sometimes going over it on the sheet first of all, and then going over on the recording, because going over on the sheet, you know, when you're doing the recording, it's kind of going over more quickly, and if you go over it on the sheet first of all, you're kind of able to go more at your leisure sort of thing. And once you kind of get that as a basis, then I think going over the recording will help a bit more. Okay? All right. So so thanks for coming, Jaron. And I will, I'll send out this recording. And if you do have any questions about the assignment, just give me a shout.